In the early stages of growth of a population, we can say that the population grows uninhibitedly following the exponential law. Let's look at an example. Suppose that the function n of t equals 100 times e to the 0.045 t power. What we're going to do is analyze this function by answering a few questions. The initial question that we want to answer is, what was the initial amount of bacteria in this population? To find that out, we just evaluate the function at t equals 0. We get n of 0 equals 100 e to the 0.045 times 0 power. Well, this becomes e to the 0 power, which of course is 1. We have 100 times 1, so the initial population is 100 grams. The next thing that we want to do is identify the growth rate. The growth rate of the population is given by the coefficient of t and the exponent. So the growth rate is 0.045. If you want to express this as a percent, we could say that the growth rate is 4.5%. Now let's go ahead and graph this function using our graphing calculator. We enter the function into the graphing calculator. We set the viewing window as follows, and we obtain the graph of the function. Next, we want to know what the population is after 5 days, which means we're going to find n of 5. So we let t equal 5 in our function, and that gives us 100 times e to the 0.045 times 5 power. We evaluate this in our calculator, and we get that the size of the population is 125.2 grams. Next, we want to know how long it will take before the population reaches 140 grams. That is, we're solving n of t equals 140. Well, n of t is given as 100 e to the 0.045 t power. What I'll do first is divide both sides of the equation by 100. That gives me 1.4 equals e to the 0.045 t. All I need to do here is rewrite this expression as a logarithm. I get 0.045 t equals the natural log of 1.4. Finally, divide both sides by 0.045. I get that t is the natural log of 1.4 divided by 0.045, and we get that t is about 7.5 days. So the size of the population will be 140 grams after about 7.5 days. Finally, we want to know the doubling time of the population. Remember, the initial size of the population is 100 grams, so it'll double when the population reaches 200 grams. That means we're going to be solving 200 equals 100 e to the 0.045 t power. Divide both sides of the equation by 100. You get 2 equals e to the 0.045 t power. We rewrite this expression as a natural log. We get 0.045 t equals the natural log of 2. Finally, divide both sides of the equation by 0.045. We get t is the natural log of 2 over 0.045, and that we get about 15.4 days. So the size of the population will double after about 15.4 days.